Get rid of the damn thing.
I want to see.
Why were you actioning twice? I thought someone was gonna walk in front of the camera.
You guys redoing these?
Second time.
We're at the Twisted Pear. Okay.
Should be here in about 20 minutes. They said 45 minutes.
Did you order from Domino's? Down in Moe's?
No, Divine.
Who? Okay. Oh, that's such a nice thing.
This tape covers an overview of ONS architecture, sample application environments, and accomplishments to date. A key objective of ONS has been leveraging existing technologies and products available within NCR Corporation. As such, ONS is based on NCR Tower 800 series and utilizes application processors, file processors, and terminal processors existing within Tower. The operating system is AT&T's version 5 Unix, adapted for a multiprocessor environment. The communication software is an optimized version of the software supplied by SC San Diego. The system network control and management is based on NCR Net Manager as supplied by SC Columbia. In addition, the system incorporates a graphics, window, and icon-based console. The hardware platform for the console is NCR PC916. The IOP is being developed by NCR Compton. It is a RISC processor-based board that converts the tower into an optimized network and communication processor. It functions as a floating communication coprocessor across the application processors. The CB is the existing NCR Compton communication base that provides V.35 and 64 kilobit per second connectivity. It was brought forward by incorporating a multi-bus 2 interface. ONS can solve a variety of communication and networking problems. The following scenarios are examples of existing customer problems. These problems are classified as terminal emulation and protocol conversion, integration and unification of management architectures and methodologies, and bridging and gateway. This is one of the two problems related to terminal emulation and protocol conversion. The problem is provision of access for async devices to application in the IBM host, and also provision of access for PC and 3270 devices to applications within the DEC host. The solution is establishment of an ONS backbone that provides the needed terminal emulation and protocol conversion. In addition, the ONS Network Control Center will manage and control the ONS backbone. This problem is the second problem related to the terminal emulation and protocol conversion. The problem is provision of access for async devices to applications within the IBM host, and also provision of access for PCs and token ring devices to the HP hosts. The solution is also establishment of an ONS backbone, an Ethernet-based backbone that provides the needed terminal emulation and protocol conversion. In addition, a console attached to one of the ONS within the backbone could be used to manage and control the backbone. This problem is related to interoperability across multiple vendor networks and integration of a set of network management facilities. Again, an ONS backbone can provide the needed connectivity and interoperability. In addition, the Network Control Center provides a unified set of facilities for management and control of multiple vendor equipments. This problem is related to bridging and gateways. The customer has multiple local and remote LANs, hosts, and networks. The requirement is to provide bridging across homogeneous and heterogeneous LANs. In addition, to provide gateway across networks and hosts. The solution is provision of an ONS with bridging and gateway facilities. This ONS can provide local bridging across the LANs and also remote bridging. The bridging could be across homogeneous as well as heterogeneous LANs. In addition, this ONS can provide gateway between X400 in the OSI network and SNADs in the SNA network. Our progress continues towards GCA in first quarter 91. A tower 800 has been connected to a computer protocol CS410 through a set of X25 links. The TCP/IP Ethernet attachment on CS410 is used to provide a second connection between console and tower 800. In addition, the CS410 is being used for performance testing of X25 software available from SC San Diego. The NCR Net Manager-based system and network control and management for tower and CS410 is under development and testing. The console provides a unified management and control for ONS and CS410. A computer protocol CS410 is a multiprocessor machine with a wide variety of connectivity and networking capabilities. The system is Motorola 68000 and Multibus 1 based. A Tower 800 is configured with multiple APs, TPs, and FPs. The NCR PC916, which serves as ONS console, is configured with X window card, Unix, and a 19-inch monochrome monitor. A 20-inch color monitor is also being tested and incorporated within the ONS console. A tower view will also be prototyped when support for the Tower 800 becomes available. A Sun 386i with a set of graphic tools is being used as a prototype platform for proof of concept. The resolution and color capabilities of the color ONS console will be compatible with this system. The ONS human interface paradigm is a high-level methodology for A, organizing human-machine interaction, B, providing management facilities and attachment of these facilities to the appropriate context, C, providing an implementation roadmap, and D, tracking user interaction. The network view provides a graphical representation of the customer network. The nodal view accepts inquiries about the geographic location of a center and also about the set of facilities available at the center. The communication center view provides a graphical representation of customer equipment at the center as well as a set of problem management facilities. The trunk view accepts inquiries about the nature and the utilization of a trunk. The system view gives a graphical representation of the internals of a system and provides a set of facilities for the examination and manipulation of these internals. And finally, the network boundary view provides a graphical representation of the lines, trunks, and networks attached to a system. This view also provides the facilities for examination of the bandwidth utilization of these items. Our current emphasis and starting point is the system view. The user's interaction with the system starts with the user specifying the network that he or she will be operating on. This is accomplished through clicking on the icon representing the network. A view of the network appears on the system. Moving down the human interface paradigm hierarchy, the user selects Minneapolis as a desired center. Again, this is accomplished by positioning of the mouse on the Minneapolis node and clicking. A view of the center is displayed on the screen. This example displays a center as it exists in Advanced Systems Laboratory. A Tower 800, a computer protocol CS410, and the ONS console. Note that the console itself is part of the network, and as such, it is subject to the same set of management and control methodologies as any other component. Moving down the human interface paradigm hierarchy, the user will obtain access to a set of management facilities for the CS410. The CS410 management is currently integrated as a separate window. Further integration is planned. The debug monitor for CS410 provides a command and line-oriented management facility. As an example, the user can change the configuration file on the CS410 floppy disk. The user can also obtain access to the system view for the Tower 800. As you noticed, the system has displayed a view of the internal configuration of a tower system, a multi-bus 2, a master application processor, other application processors, and so on. Within the system view, a variety of performance monitoring, configuration, fault, and remote operation management facilities can be accessed. In this scenario, the user specifies that he or she would like to perform some performance measurement and monitoring on multiple boards. The system's output is displayed in a series of integrated graphs and gauges. The user has requested performance monitoring of 3 processor boards. The system is displaying the information in separate graphs. These graphs are updated on an interval basis. The value of the interval is selected by the user. This integrated graph contains a percentage of the time the board is executing operating system code, user code, performing swapping, and the idle time, all in one integrated graph. As additional performance monitoring example, the user can request the traffic intensity at the boundary between the X25 link and the system. These gauges display the requested intensities in terms of characters per second and frames per second. The user can manipulate multiple active windows on the screen and utilize the available real estate on the screen best suited for the interaction. For examples, windows can be enlarged and overlaid. The existing visual administrator facility of the tower has also been brought forward into this environment as a separate window. Related to customer support, there are 3 ongoing satellite projects. These are ONS Consular, Simulation, and High Availability. ONS Consular is a PC-based system utilizing hypertext technology. This system provides an online documentation and problem diagnosis capability targeted at various classes of users. A prototype based on Hypertize has been implemented. SafeCost is based on CSIM from MCC. This system and toolkit provides a graphics-based simulation environment where users can predict system and network performance on their various loads and configurations. This system will accompany ONS throughout its lifecycle. Currently, SafeCost is being used as a design tool within the advanced systems. High availability will be incorporated into ONS on an incremental basis. A task force is in operation. We are currently at the prototyping stage for the first increment. The CB board with multi-bus 2 interface is under test at the Advanced Systems Hardware Laboratory. The design of the RISC-based IOP board with the video RAM memory technology and 4 Ethernet interface is complete. The first unit will be available for testing in a few days. Advanced Systems Software Development and Integration Laboratory is well established and has been operational for 3 months. This is the Advanced Systems recreational facilities. And this is the sandbox area. These facilities have been operational for also 3 months. Shit.
Yeah, he thought it was great. Did you cut it?
Steve, let's see.
You didn't have the fade set in properly.
I know, I didn't have time to set the damn This damn box is coming in. It's still going, I think, isn't it? Where's the stop button?